So AAF kids, again, I need to be out today, so please make sure that you pick up a warm-up from the sub, and you probably should try to do this yourself without me. Maybe pause the video, work together, see what you can do without me, because as you can see at the bottom there, we are going to have a quiz, right? A quiz on rational functions, graphing rational functions on Tuesday. You'll be ready, I promise. Alright, so assuming that you have tried to do this yourself, let's imagine this was given to you on the quiz. So the first thing I'm asked to do is graph and label critical points and critical features. So think about the things that I've asked you to do so far, right? Critical features are not part of the equation. They're not points on the graph, but they're important characteristics of a rational function. What can you think of? Right? Vertical asymptotes, horizontal asymptotes, holes, swooshes. Those are all features. What kind of points have you had to label? You've had to label X and Y intercepts, axial intercepts, and any obvious max and mins. So let's see what we have here. What do we notice? Firstly, let's factor this denominator and factor the numerator. What do we have here? X plus 2 and x plus 1. And then how about the denominator? X plus 2 and x what? Minus 1. So the first thing I do is the domain. Domain is all real numbers except x cannot be -2, x cannot be 1. Now let's go and clean up the function. What matching factors do you have, if any? X plus 2 goes away. So right away you know that that means you're going to be graphing a hole at -2. But since this factor does not match, you're going to be drawing a vertical asymptote at 1. So let me go over here and do that. And I think I'm going to make my scale go by 2, so this is going to be a 1, 2, and 3. -1, -2, -3. So at x equals 1, I'm going to draw my vertical asymptote. And then I know at x equals -2 there's going to be a hole, right? So I'm going to say my cleaned up function is x plus 1 over x minus 1, and I'm going to use my cleaned up function and figure out where my hole is, right? So I'm going to plug -2 plus 1, -2 minus 1, and I get -1 over -3. Check my math, am I right there? Which of course is positive 1/3. So at positive 1/3, I'm sorry, at -2, positive 1/3, I have a hole. Oh, that's a terrible hole. Now what else do I need? I can use my cleaned up function for my x-intercept and my y-intercept. So for my y-intercept, I'm going to plug in 0 for x. So let's change this to a 0 and a 0. And I don't get negative, I get positive 1 over negative 1, aka negative 1, right? So 0, negative 1 is my y-intercept. How do I find an x-intercept? I go to the function and I ask the numerator, what x makes you equal to 0? Because remember, I don't care about the denominator when I'm looking for a fraction equal to 0. I just need the numerator to 0. What x is that? Negative 1. Lastly, I go and think about my horizontal asymptote. We learned for rational functions, we have a neat little trick. Instead of plugging in infinities or negative 1,000, negative 1,000,000, 1,000, 1,000,000, we can just look at the degree of the numerator. And since the degree of the numerator is the same, the horizontal asymptote is going to be at a ratio of the leading coefficients, which is 1 over 1. Now at this point I'm going to use my calculator and verify the shape that I think I'm going to have here. Okay. Now the only thing left to know is I wonder if my horizontal asymptote is ever used, right? Nobody asked me for the range, but remember, what did we say for the range? My suspects for the range are 1. Do I kick out y equals 1? Do I kick out y equals 1/3, the y value of the whole? So I ask the cleaned up function, hello function, will you ever equal 1? I multiply both sides by x minus 1. And I get x minus 1 is equal to x plus 1. The x's here cancel out, and I get negative 1 is equal to positive 1, which is a false statement. So I know that this function will never hit y equals 1. Right? So this is out of the range. My graph is pretty correct. Now, nobody asked you to do this. I'm only just demonstrating something. If I was asked for the range, right? Oh, gee, look what they asked me right here. Mwah, mwah. So since I was graphing, I was going to go ahead and do this math, and notice that it asked me to show that, right? This is me showing. I plugged in 1 to the function and asked it, and I got a false statement. Therefore, the range does not include I can't spell. Now let's ask it about 1/3. So this time I say to the function, hello, let me go, where can I go over here? Will you ever equal 1/3? Same thing, I'm going to multiply both sides by x minus 1 and get x minus 1 over 3 is equal to x plus 1. Multiply both sides by 3 and I get x minus 1 equals 3x plus 3. That means I get, oh, this is terrible space management. I'm going to go up here and I'm going to say 2x is equal to I'm going to move this x over here and this x over here, so I get 2x is equal to -4. So x is equal to -2. So there must be a, oh, what? Wait a second. X is equal to -2 makes no sense to me, right? Why? Oh, all the way back at the domain that nobody asked me for. But the domain says that x will never equal -2, so this is also nonsense. The range also does not include 1/3. So you see, I knew where this was going, so I went ahead and as I was graphing decided, oh, I should think about the range, which you really should, right? So I know I can't touch the horizontal asymptotes at the ends, but I wondered if maybe this function came down and back up. But hey, can you bring me your calculator? So that's why I naturally went to ask the questions and found out that neither the y value of the whole nor the y value of the horizontal asymptote was ever touched, meaning this red function is a one-to-one function. Okay, but but you don't, just to be clear, you don't have to do that process unless this question is asked. Show that. Okay. So now let's go to the next questions. Notice that the next questions all say justify, justify, justify. Remember with the word justify, that's when I'm going to be a little more fancy about the language that you use. So the justify should mean to you infinity behavior. So a horizontal asymptote will exist at y = 1 if and only if, as x approaches both positive and negative infinity, what are the y values doing? Right? And how do I verify that? That's where you go to your calculator, right? But I can also see because of my graph, which you used, right? We already have this, which we got from our calculator. As x goes to the right end of the domain and the left end of the domain, the range values all approach 1. Therefore, don't forget it asks you to justify. There is a horizontal asymptote at y = 1. For a vertical asymptote, though, at x = 1, this time you're talking about domain, so you have to say as x approaches 1 from, let's go from the left side first. Look at your graph. What are your range values doing? They're swooshing. Which way are they swooshing? At the left. They're swooshing what? Down. But as x approaches 1 from the right side, f of x is swooshing which way? Up. Therefore, there is a vertical asymptote at x = 1 because you swoosh on both sides. A hole, you best not swoosh, right? At x = 2, at x = -2, there was a hole. There was no swooshing. So what happened? As x approached -2 from the left, and as x approached -2 from the right, what were the range values approaching? Okay, so again, I'm going to go over here to 1. The range values were swooshing down, swooshing up around 1. But what are the range values doing here at -2? They're not swooshing anywhere. They're approaching a height from the right and from the left. What value is the graph approaching? Okay? Lastly, let's go to concave up and concave down. Now, you best check domain. These have to be domain values. Remember, -2 and 1 do not exist in your domain, so they cannot exist in any concave up or concave down intervals. Do you agree that you start -infinity? Now I'm going to color up here, right? What are you? Concave which way? That's concave down, from -infinity to the x coordinate of the whole. Then what are you? Concave down from -infinity, don't say to -infinity, -infinity to what x value? 1. Nothing's happening at 1, and now what are you past 1? Concave which way? Concave up from the x, from the vertical asymptote, all the way to positive infinity. Okay? All right, let's do some practice then. With the characteristics. We've done a lot of the characteristics. Right? What is the domain? What is the range? We did all this work already. We have found out that the y coordinate of the horizontal asymptote and the y coordinate of the whole are not going to be used. Yes, this rational function is a function, right? This is a parabola divided by a parabola. It is not continuous because the parabola in the denominator has numbers that create 0. This rational function was 1-to-1. There was no absolute max, there was no absolute min, and there were no obvious maxes and mins on the inside. The x-intercept was -1. The y-intercept was, I forget, what was the y-intercept? No, was it the x-intercept? What was it? I forget now. What was this? This was x plus 1 over x minus 1. The y-intercept was -1. Oh, and the x-intercept was -1 too. That's right. Right? Yes. Sorry. We found the horizontal asymptote was y equals 1. There was a vertical asymptote at x equals 1. There was a hole at -2 1/3. We did the concave up and concave down intervals already. -infinity to the x coordinate of the whole, the x coordinate of the whole to the vertical asymptote, and then concave up from the vertical asymptote to the right side of the domain. How about increasing and decreasing? Right? What did this function do? I'm going to just draw it rough here, right? What did my pen do the whole time? Decrease. There was no increasing. But don't forget, you were decreasing from the left side of the domain to the x coordinate of the whole. Then the x coordinate of the whole to the vertical asymptote. And then the vertical asymptote to the right side of the domain. Okay? So the characteristic list happened very quickly once I'd done all that other work. Domain comes from factoring the denominator. The range comes from your suspect list. You're always going to be a function. Continuity depends upon if you had any bad x's in the domain. So look at the domain for this. 1-to-1, look at the graph. Look at your picture. Same thing for max and mins. Look at your picture. X-intercept and y-intercept do algebra. Vertical asymptote comes from your domain. Whole comes from your domain. And then plug in this comes from your rational function trick, where you're looking at degree of the numerator and denominator. And then increasing, decreasing, concave up and concave down all come from your picture, your graph. Okay? So here's a picture of the homework from the book, page 377, right? Number 21. Right? Because that factor canceled out, I had a whole at 4. And then here's my cleaned up function that I used for everything else. Since x minus 3 and x minus 2 didn't, x plus 2 didn't factor out, I had vertical asymptotes there. I plugged 4 into the cleaned up function to get a half. I plugged in 0 to the cleaned up function to get 1/6. I set the numerator equal to 0 to get the x-intercept. The degree of the denominator was numerator degree 2 over degree 3. Since the denominator was more powerful, my horizontal asymptote is at y equals 0. Then I put this function into my calculator and looked at the graph, knowing that there had to be a graph everywhere else. I taught you how to look for swooshes. If you are on a quiz or a test and you can't find your graph, I told you how to use that second table set where you can look at, you know where your bad x's are. You know where your bad x's are. You know where your hole is. You know where your intercepts are. Then plug in what's happening around -2, what's happening at -100 and -1,000, +100, +1,000. Notice that this rational function is not one-to-one. Notice the y value of the whole is used again over here. Notice that the y value of the horizontal asymptote is used here. Right? This function is not one-to-one. Here's the next two. Right? Notice the process does not change. Right? This one was a little ugly. Ew. Right? I won't give you something this devastating on a quiz or a test, but it's good to practice. Right? It is just algebra. What I wanted to make sure, see, there's an actual little minimum here I would not expect you to find. By the way, that's a terrible looking graph. But this is an obvious turning point. I expect you to use your calculator and do second trace minimum or second trace maximum to find any of these. There's also a small minimum over here, right? A very hard to see minimum here. Not expecting you to go find that one. But this one, yes. Okay. All right, so let's practice that justifying again. I did that in the warm-up. So these really go together, right? All you're doing is don't have to do any algebra. You're just looking, right? Just look at the graph. What's happening is x equals -4. As you approach -4 from the right and you approach -4 from the left, what are the y values doing? The y values are approaching, and you're just reading from the graph, so whatever you want to call that, I'm going to call it 1. Since the graph is not going swoosh anywhere, it's approaching a height of 1, Therefore, there is a hole at x equals -4. So can you do the rest? I bet you can. At -3, as x approaches -3 from the right, what's happening as x approaches -3 from the right? What's f of x doing? Swoosh! As x approaches -3 from the left, what's y doing, or f of x doing? Swoosh! So from the right, swoosh down. From the left, swoosh up. Therefore, at -2 from the left, from the right, approaching a height. Therefore, there's not a vertical asymptote because there's no swoosh. Same with 2. 2 from the left, 2 from the right, also approaching, I think that's -1. Again, I don't really care what y value you call it. But it's not a vertical asymptote. There's no swooshes. But what's true at 3? As x approaches 3 from the right, swoosh up. As x approaches 3 from the left, swoosh down. From the right up, from the left down. Therefore, there is not a hole because you didn't approach a level. You approached infinity. Finally, at 4, for the domain, approach 4 from the right, approach 4 from the left. Therefore, you do not have a vertical asymptote. There's no swoosh. You have a hole. Finally, that was all domain. All of this was about the domain. Right? As x approaches a domain number. Now, as x approaches, these are domain numbers. Now this is domain ends. Right? As x approaches infinity, as x approaches -infinity. So as x goes way out here, slide. As x goes way out to the right, what's the graph doing? Slide. Where are they both sliding to? Therefore, what must be true? Not a hole and not a swoosh. It's a slide. And a slide is a horizontal asymptote. This is what the word justify means. Justify means you've got to talk to me in this language, okay? Now here's something else a little interesting, don't you think? I don't know what equation generated this graph, but I can tell you that there was 1, 2, 3, 4 factors in the denominator that were also in the denominator, right? X plus 4, because that's the only way to get a whole. X plus 2, x minus 2, and x minus 4. The only way to get a whole in a rational function is if you have factors canceling out. So what about the vertical asymptotes then? The vertical asymptotes means there were factors in the denominator that did not cancel out. And where did that happen? At 3 and -3. Now there might be some other things going on and maybe a dilation factor, but certainly what's the degree of your numerator right now? The degree of your numerator is degree 4, and in your denominator is degree 1, 2, 3, 4, 5, 6. So isn't it true that you're bottom heavy? And if you're bottom heavy, you have a vertical asymptote at 0. Another wacky thing about this function, think about the range. The range actually has a gap. Can you see that? Now this you wouldn't be able to do algebraically. You would do this just by looking at a graph, but can you see the range goes from negative infinity, to, let's say that's 0. I'm sorry, let's say that's negative 1. And then there's a gap, right? Nothing is used from negative 1 to 0, right? So then the graph starts again right after 0, but goes to a height of 1, where there's a hole here and a hole here. So the height of 1 is not used by either branch. And then the range goes to infinity. Wow. These graphs are crazy, whack, funky! Sorry, my dog thinks I'm crazy now. All right, so here's another handout. Yep, another one. Let's practice. So again, maybe I suggest that you try this without me, and then right, and then see what if you can compare with mine. So I'm asking you to write an equation of each vertical asymptote, or state that there is none, each horizontal asymptote, or state that there is none. Write a formal justification for each asymptote and whole. And then this is just a pondering question. How do you think you justify if there is not a horizontal asymptote? All right, so let's start with number 1. There's going to be a vertical asymptote at x equals negative 2. Do you know why? Right. Because that's the only number that makes the denominator 0. This numerator doesn't cancel out, so that would be a vertical asymptote, not a whole. There is no horizontal asymptote because you're top heavy, right? The degree of the numerator is 1 and the degree of the denominator is 2. So there is no ha. We also know there's no whole. Now I just went over formal justifications, so I'm not going to do it here, but I will do one where we've got more of these, right? But you should practice writing formal justifications. You would only have to do the vertical asymptote here. What about the next one? This is tricky, yeah? Right? As soon as you see a fraction, you worry. You worry about what makes the denominator equal to 0. Well, what numbers? Remember, you're only dealing with real numbers. What can you square and get negative a half? Nuttin', honey. So if there is nothing that makes the denominator equal to 0, that means this function is continuous. It must be continuous. That means there's no vertical asymptote because there was nothing in the denominator to equal to 0. And if there's no vertical asymptote because there's no factors that make the denominator 0, there's no factors that would cancel out, right? What about a horizontal asymptote, though? Look at the degree. Squared over squared, equal power. So your horizontal asymptote is at a ratio of the leading coefficients. Crazy. All right, let's look at number 3. Number 3 has a whole bunch of domain issues, right? we have bad x's. Domain. X cannot equal 2. X cannot equal -1. X cannot equal 5. X cannot equal -2. But then notice that we do have a factor to cancel out, right? X plus 2, leaving a 1 in the numerator, times 1, and x plus 2, meaning that at -2 there's a hole, but there's 3 vertical asymptotes. Right, so I have a hole at -2 comma something, and I have a vertical asymptote at x equals 2, x equals -1, and x equals 5. This graph is certainly not continuous. Where's my hole? My hole is at plug -2 into the cleaned up equation. So you get 1 over -4 times -1 times -7, and that is -1 over 28. Check my math on that. How about a horizontal asymptote? Well, the power of the denominator is a 1. What's the power of the denominator? 1, 2, 3, 4. So you're bottom heavy, so you have a horizontal asymptote at y equals 0. All right, let's look at number 4. I gave you a hint because that denominator, 4x cubed, I start to sweat when I see 4x cubed. I'm like, well, I can't factor that, but you have a calculator. It's not one of your special cubes that I taught you how to factor. So just put the denominator alone, just the denominator, into y1 and see what numbers make it 0, if any. It's a cubic function, so there might be 3, right? But when you put it in your calculator, I see it's a cubic function with only one x-intercept, so I did second trace intersect. I'm sorry, I did second trace 0. And I got from my calculator a half. So 4x cubed plus 2x squared minus 1 equals 0. Whoops, equals 0 at x equals 1/2. Is x equals 1/2 a factor of the denominator? I'm sorry, the numerator. I can factor the numerator, but I get 3 minus x squared. No, that is not. Right? X minus 1/2 is not a factor of the numerator. Therefore, this is a vertical asymptote. Okay? It's a number that makes the denominator 0, and it does not cancel out with any factors in the numerator. Therefore, there must be a vertical asymptote at that number, x equals 1/2. There is no hole because there was only one number that made 0 in the denominator, and that was 1/2. Now, how about a horizontal asymptote? Horizontal asymptote. I'm about to make a mistake. See if you can catch it. The degree of the denominator is 3, and the degree of the numerator is 1. Therefore, the horizontal asymptote is at y equals 0. I don't think so, right? The assumption, when you talk about the degree of a polynomial expression, you mean the highest degree. So, whoops, they didn't put this, right? They put it in the wrong order. This is something you practiced in Algebra 1. This is -5x cubed plus 3x over 4x cubed plus 2x squared minus 1. So what is true about the power of the numerator and the power of the denominator? They're the same. And what happens if the power is the same? When you go off to infinity or positive infinity, the ends get pulled off to a ratio of the leading coefficients. The leading coefficients. All right. Now last one. Notice I only have an x in the denominator. What number makes the denominator equal to 0? That's right, 0. So there's only one bad x. Your domain is x cannot equal 0. And that's not a factor in the numerator. Therefore, there is a vertical asymptote at x equals 0. There is no hole because there was no factor that canceled out with x. How about a horizontal asymptote? The degree of the denominator is 1, but what's the degree of the numerator? You have an x to the first times an x to the first, which is an x squared. So since you are top heavy, the denominator is stronger, there is no horizontal asymptote. Okay? So over here, I'm going to do some justifications. I'm not going to do them all. I leave that for you to do. I'm going to justify the vertical asymptote for number 1. I don't even need the graph. I know it's a vertical asymptote. As x approaches -2 from the left, as x approaches -2 from the right, f of x swooshes. Which way does it swoosh? If I'm not sure, just guess. Put positive or negative infinity for one of them and say, therefore, there's a va at x equals -2. Just guess if you're running out of time. Here's how, without a calculator, I figure this out. Talk to me about putting in 2. I'm sorry, -2. We can't put in -2, right? You're not allowed because -2 makes this denominator 0. But what if you put in -2.01? What does that make your denominator? -2.01 plus 2. What does that give you? Isn't that -0.01? And then what happens if you put -2.01 here and square it? Isn't that a positive number? Positive number times a +3 is what? A positive number. Times a +5. Don't you get a positive number? Well, if you have positive numbers over really, really small negative numbers, guess where you're going to do? You're going to swoosh down, hun. That's -2 from the left. What about -2 from the right? Go back up here and you're going to enter -1.99. -1.99. Talk to me about the denominator now. Isn't it still really small? -1.99 plus 2, but it's a positive number. And then look at your numerator. I don't care actually what this number is. You're squaring it and multiplying times a +3 and adding 5. It's also going to be positive. What's a positive divided by a really, really small positive number? Positive swoosh. I don't need you, calculator. See that? All right. Now let me go and justify the horizontal asymptote for number 2. For a horizontal asymptote, it says x approaches both the right and the left end of the domain. Your function approaches the y coordinate of the vertical asymptote. So I'm not really proving anything. I just saw this on my graph. But again, even without a calculator, go over here into these x's and put in 1,000,000. 10 to the 6th. 10 to the 6th. If you have $1,000,000 and you square it, somebody multiplies it by 3 and adds 5, it's still pretty close to $1,000,000 squared. And how about your denominator? $1,000,000 squared. Somebody multiplies it by 2 and adds 1, it's still really, really close to $1,000,000. And what is $1,000,000 times 3 divided by $1,000,000 times 2? 3 halves, because the 1 millions cancel out, and no one cares about this plus 5 and plus 1, right? You have $1,000,000 squared times 3. Does anybody really care about the plus 5? I don't think so. All right, let me go justify the whole in number 3. Again, I'm just writing as x approaches -2 from the right, and as x approaches -2 from the left. And again, I just saw this on my calculator and with my algebra that the f of x values approach -1/28. Since there is no swoosh, and that was a bad x, there must be a hole. Okay? So there you go. Last thing, how do you think you justify there is no horizontal asymptote? Well, which problems had no horizontal asymptote? Right, number 1 and number 5. So let's look at number 5. How do you think you justify that there's no horizontal asymptote? Well, remember what you're looking for. You're looking for what happens at the ends, right? At the ends of a function. So what's true about this? This is x times x. This is x squared over x to the first. What does that reduce to? I know there's other terms here, but just the most power, the most influence at the ends, x squared over x reduces to what? Positive x. Plug infinity into there. What happens? Plug infinity into x. Doesn't it go towards infinity? So 1,000,000, 100,000,000, a gazillion. When you plug in a gazillion, you get a zillion back. So as x approaches positive infinity, this rational function approaches infinity. How about as x approaches negative infinity? And again, I don't care about the middle terms or the y-intercept when I'm talking about plugging in -1,000,000. If you plug in -1,000,000 squared over -1,000,000, that's going to be the same as just plugging in -1,000,000. And where does that go? Negative. So do you level off? No, you don't level off. A horizontal asymptote for rational functions has to level off on both sides. This is an extra. This is an extension here. You're not going to be responsible for that on the quiz, but you're going to be responsible for vertical asymptotes, knowing where they are, graphing them. Horizontal asymptotes, knowing where they are, graphing them. Holes, where they are and graphing them. And you're going to be responsible for formal justifications for both kinds of asymptotes, vertical and horizontal, as well as holes. And then, of course, graphing, labeling, and listing characteristics of any rational function I would give you. I will not give you ones like the book problems. Those were also like at the end. At the end of, when we've done a whole bunch. I didn't give those to you at first. Our first three handouts, rational functions 1, rational functions 2, rational functions 3. That's what you should study for the quiz. All right. So again, remember your homework going all the way back. Your homework is to finish the handout that I just did with you. Aren't I nice? All right. Have a great weekend, and I will see you on Monday.